here we have a circle with the center at the point O. We also have a square, CF and O. We draw a diagonal in the square, CM, that intersects the circle at the point D. We create an angle CDE of 40 degrees. And we ask to find the angle between the side of the square CF and the segment FE. So how are we going to solve this problem? First of all, there are a bunch of angles here, so it's good to talk about inscribed angles, central angles, and to do that we need to extend certain lines in this drawing. First of all, let's extend the line CD until it intersects the circle at the point G. We also extend line FC until it intersects the circle at point H. The next thing we would like to do is to talk a little bit about a very useful concept, and that concept is called measure of an arc of a circle. So let's imagine we have a circle with the center at the point O. We draw an angle AOB, this angle called central angle, because it goes through the center of a circle. And now if you look at the arc, this angle intercepts the arc AB. We're going to say that the measure of this arc equal to the measure of the central angle that intercepts that arc. Another useful concept is a concept of inscribed angle. So if we pick up point C somewhere on the circle outside of this arc AB and connect point A and point B with this point C, we're going to get the angle ACB. That's an inscribed angle that is intercepting the same arc as the central angle AOB, and therefore this inscribed angle will be half of the measure of the central angle. So now we can use this concept to solve our problem. First of all, notice that our angle X intercepts the arc HE, and the measure of this arc will be 2x since the measure of the inscribed angle is x. The next thing, notice the arc GE, and this arc is intercepted by the angle of 40 degrees, therefore the measure of this arc will be 80 degrees. And now what we see, we have this green arc, we have the red arc. The difference between them is this yellow arc. And since we know GE, we would like to find HE. All we have to do is to find the measure of the arc GH. And let's do it next. First of all, let's remind ourselves the definition of the measure of the arc of a circle. That's the measure of a central angle that intercepts it. So that would be the angle GOH. So we can solve the problem and find x if we find the measure of this angle GOH. So how can we do this? First of all, let's find the measure of this angle AOH, angle between horizontal line AB and the segment OH. To do that, what we're going to do, we're going to reflect our green square over horizontal line AB. We're going to have another square right here. And on this square, this point F, under this reflection, become this point H here. And we can see that our segment OH is a diagonal of the bottom square. And therefore there will be 45 degrees between the diagonal of the square and the side of the square. The next thing we would like to find is this angle AOG. To do that, we need to look at this triangle GFO. It turned out that this triangle is equilateral. And the reason why it's equilateral is, first of all, notice that this triangle is isosceles. We have a side GO and side FO. Those sides are radii, and therefore they have the same length. The next thing to notice is that CN and FO are diagonals of the square. Therefore, they split in half at the point M, at the point of intersection, and also they're at 90 degrees to each other. So what it means is that GM is side FO bisector, and also it's an altitude of this triangle. And if I have a triangle in which one line is both altitude and side bisector, it means that I'm dealing with isosceles triangle. And that means that GO equal to GF. And we already know that GO equal to FO. So it means that all three sides have the same length, and we prove that this triangle is equilateral. So we know this angle O here, FOG, is 60 degrees. And we also know that the top part of it, FOA, is 45 degrees, because that's the angle between the diagonal of the square and the side of the square. Therefore, the other part, angle AOG, should be 15 degrees. And now what we see, that the big angle AOH, as we said before, it's 45 degrees. Part of this angle here is 15 degrees. So the other part should be 30 degrees. But that means that the measure of this yellow arc, GH, is also 30 degrees. And now if you look at this formula that relates the measures of the arcs, we see that green arc, which is 80 degrees, equals to 30 degrees plus 2x. And from here we can easily find that x should be 25 degrees.